Most developers hardcode IP addresses in Kubernetes, but there's a better way. DNS makes service discovery automatic, elegant, and resilient to pod restarts. Kubernetes runs CoreDNS as a cluster-wide DNS provider. When you create a service, CoreDNS automatically registers a DNS entry following a specific format, servicename.namespace.svc.cluster.local. For example, myapp.default.svc.cluster.local. Any pod can resolve this name to reach the service. How does a service know which pods to route traffic to? Services use label selectors. When you define a service with a selector like app equals myapp, Kubernetes creates an endpoints object, or in newer clusters, an endpoint slice, that tracks all pod IPs matching those labels. As pods scale up or down, these endpoints update automatically. The DNS name doesn't resolve directly to pod IPs. It resolves to a stable virtual IP called the ClusterIP. This ClusterIP never changes, even when pods restart or move. Kubernetes proxies traffic from the ClusterIP to the actual pod IPs listed in the endpoints, providing a stable target for your applications. Finally, pods don't need manual DNS configuration. The kubelet automatically injects DNS search domains into every pod, so you can use short names like myapp instead of the fully qualified domain name. This makes cross-service communication incredibly simple. To summarize, CoreDNS provides automatic DNS registration, services use label selectors to discover pods via endpoints, and the stable ClusterIP ensures your apps always find their targets. Master this flow, and you'll ace any Kubernetes networking question. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.